Okay, so this is 1.2. We're going to talk about the introduction to whole numbers. Okay, so 1.2, introduction to whole numbers. We're going to discuss place value, standard notation, and expanded notation, writing numbers in words, either in the proper way, and then the number line and line order. Okay, so let's talk about place value. Okay, you don't have to write every single thing down. Like I said, it will be online. All of our numbers are composed of 10 digits, 0 through 9. Okay, and basically every number 0 through forever is known as a whole number, as long as you don't count any decimals or fractions and there's no negatives. Those are whole numbers. So 0, 1, 2, 3, 4, 5, it goes on and on and on infinitely forever. Commas are used to separate digits into 3 groups. Those are called periods. So if we write this number here, this is a period, this is a period, and then this is a period. Okay, so those are standard form. And the positions are what determines the place value. This you may want to write down. All right. We have the ones period that covers 1 through 100, or hundreds, ones through hundreds. The thousands period covers thousands through 100,000s. You have the millions period that covers millions through 100 millions. And then you have the billions period, which is billions through 100 billions. And obviously it goes on. There's trillions, there's septillions, it goes on forever. All right, so when we're determining place value, what we're going to do is we're going to look at the 2. All right, so I have ones, tens, hundreds, thousands, 10,000s, 100,000. So the place value of this digit is 200,000. Okay, so that's how much that 2 is worth, 200,000. The place value of this 2, we have ones and tens, so it's technically it's 2 tens or 20. Right, 2 tens is 20. And here I have ones, tens, hundreds, thousands, 10,000, hundreds, thousands, millions. So this is 2 million. Yeah. Okay. The altitude of Mount Everest, which is the highest mountain on Earth, is 29,035 feet. We're going to give the place digit of each place value for each digit. Okay, so the 2 is going to give us 20,000. I'm going to write 20,000 for a reason, because it's going to help us with expanded notation. The 9 is 9,000. The 0 is no hundreds. Right? We have no hundreds. The 3 gives me 3 tens or 30. And then the 5 is just 5 ones. 5. Okay. The reason I put in the no hundreds is because when you're going from words back to a solid number, if they said 29,000, let's say they said 29,035. They didn't put any hundreds in there, right? You have to put a 0 in that space. So anytime there's something that's left out, that's going to be a 0 holding in that place. So I want you to be aware of it. Does that make sense? For that reason. So in case you're wondering why do we have to do this, it's so that you can do things that make it easier. So 4,672 is 4,000 plus 600 plus 70 plus 2. And 257,016 is 200,000 plus 50,000 plus 7,000 plus 10 plus 6.
You're on slow and you're making sense.
Awesome. Okay, so here we're going to convert to standard form. I have 2 hundreds, 5 tens, and 9 ones. I have 1,000. Look what I'm missing. Hundreds, right? There's no hundreds in there, so no hundreds, 2 tens, and 5 ones. So just be sure that you don't write, okay, you don't have to write this down, but don't write 125, because that's not 1,025, that's 125. So you don't, got to be really careful to put those zeros in when there's missing. All right, so writing number in words, some have a hyphen and some don't, okay? Whenever you have a word made up of 2 numbers, like a number that's made up of 2 numbers, like 60 and 8, anytime that happens, you're gonna have a hyphen. Okay, so if you write 23, it's gonna be 20 hyphen 3. So you might want to write down that hyphen so you have 2 set words being put together, those get hyphen. To write a 3-digit or larger, you begin at the left. You always begin at the left. So if it was 400, you'd start at the 4, so 472 or something like that. Just like when you're writing a number, you put a comma in between each period. If you're writing out long word numbers and words, you put a comma in between each period, like as the group of words. So if it was 52 million, you'd write 52 million, comma, and then 473,000, comma, and then 272. So you put a comma in the words in the same places that it falls in the numbers. So if we're going to write this giant number in words, okay, so I'm going to write 621 million. Okay, so that's this part, 621 million, comma. Oops, words. 417,000, comma, 325.
So basically just put a comma where it goes in the...
Yeah, commas match up. So commas in the words in the same places as in the numbers. And you'll notice there's no and anywhere in here. So if you're saying this number, you say it exactly the way I just wrote it. So you'd say 621,417,325. No ands. We're putting numbers into standard form. We've got 6 million, so that's going to be a 6. 46 100,000. Do you see what we're missing? We're missing the 100,000s, right? So we've got a 0 there, and then the 46,903. We've got the 900, we've got the 3, we're missing tens. So these zeros go for our missing parts.
Is that the right way?
Mm-hmm.
That means we don't have to put no.
Alrighty, so our mouth needs to eat the larger number. Which number is larger, 7 or 0? Which number is larger? You guys got that. The answer when you add two numbers together is your sum. So if you're told to take a sum, that means to add. Or what is the sum? That means to add. The two numbers that are being, or two or more numbers that are being added together are called add-ins. So you add together add-ins to get a sum. Okay. If we want to use a number line, okay, it's not perfect, but to use a number line for addition, and when we're adding positive numbers together, it's not necessarily necessary, but I'm going to show you how to do this because when we start mixing negatives and positives, it might become more useful. I'm going to start at 5, so that's right here, right? Okay. And adding literally means when I add, I move to the right. Always when you move to the right, you're adding. If you move to the left, you're subtracting. So if I move 3 spaces, 1, 2, 3, that brings me to lucky number 8. So 5 plus 3 is literally moving 3 spaces over on the number line, so now you have 8. Yeah. When we add, we want to line up the digits by place value. So ones all go together, tens all go together, hundreds, thousands, etc. And then we add straight down. Carrying or regrouping, when I went to school, we called it carrying, and somewhere along the line they renamed it regrouping. And when I first started teaching, they're like, oh, regrouping, and I was like, what is that? And they showed me, oh, carrying. So it's the same thing. We're going to add 8 and 5, but that's going to give me 13. Well, if I write 13 here, what happens here? I carry my 13 up because, think about it, ones have to line up, and then tens have to line up. So I have 13, well, that gives me 1, 10. And then I add all my tens together, so I have 1 plus 4, which is 5, plus 3, which is 8. We're going to line up all of our numbers by place value. I have 6 plus 8, which is 14, plus 9, which is 23. I'm going to carry my 2. 2 plus 7 is 9, plus 5 is 14, plus 1 is 15. Carry my 1. 1 plus 0 is 1, plus 1 is 2, plus 4 is 6. 1, 5, 7, and then 10. When we talk about a variable, it's just any letter or symbol that represents a number, and any letter can be used. In some instances, they're specific. If you're talking about like an algebraic formula, distance equals rate times time, that's D stands for the distance, R is rate, and T is time. Often T gets used for time. T is usually time. Let's see, there's E MC squared. E equals MC squared. You guys have heard about that one? Okay. E is energy, M is mass, and C is the speed of light. Those are specific. But if you're writing an equation based on a word problem, you can use whatever letter you want. So if you happen to think that Q is an awesome letter and you want to always use Q, go ahead. It doesn't really matter. Most commonly, we use X and Y. Most commonly. This seems very straightforward, right? If I add 0 to something, any number, so A is any number, and if I take any number and I add nothing to it, I get the exact same number back. That is the addition property of 0. Now, it seems fairly straightforward, right? Property of addition. All right. The commutative property of addition is that if I take any numbers A and B, A plus B is the same as B plus A. Now, this doesn't work for subtraction. It only works for addition. So, you know, if you want proof, 2 plus 3 is the same thing as 3 plus 2, right? This is 5. Hey, guess what? So is that. So it doesn't matter what order you add in. Okay. This is useful because if you have like a long string of numbers to add together, you can rearrange the order of them to put pairs of numbers together to make it easier. Just as an example, if I have 6, 3, 5, 7, and 4. Okay. 6 and 4 is 10. So I could put those together. And then 7 and 3 is 10. So I could put those together. So I have 10 plus 10 is 20 plus 5, 25. That's faster than going, okay, 6 plus 3 is 9, plus 5 is 12, plus 7. Does that make sense? So this is a useful property for rearranging things to make it easier. And you're allowed to do that. You're allowed to take a problem and you're allowed to rearrange it as long as you don't break any. Like if it's all addition, you can rearrange it however you want. If there's subtraction and stuff in there, you can't change that order necessarily. But for addition, you can rearrange it however you. So if I'm going to rewrite using commutative property, that just means I switch the order. Commutative switches the order. Another way to think about it, you've got your morning and your afternoon commute. You go from home to school and then you go from school to home. The only thing you did was change the order. Okay, for associative property, all associative property does is move the parentheses over. So it just changes the groups. And associations are groups, right? You have the National Association of Women. It's a group of women. You know, the American Heart Association. It's a group of heart doctors. So associative property just changes groups. Yeah. So we can call it reverse or opposite operation. Okay, subtraction is the reverse or opposite operation of addition. They undo each other. Okay. In addition, both parts are called the addend because it doesn't matter what order they go into, but in subtraction they have different names. The first one is called a minuend for minus, and the second one is called a subtrahend, and then the answer is the difference. So this is the first number, this is the second number, and this is the the answer basically.
Minuend?
Minuend. So you have minuend minus subtrahend equals difference. Okay, does anybody need to write this down? Okay. All right. Oops, that's not what I meant to do. We've got subtraction, 8 minus 2, 6. To check it, you would do 6 plus 2. That would be 8. Okay. Subtraction and addition are opposite of each other. 10 minus 6? 4. If you want to check it, you do 4 plus 6. 5 minus 0? 0 plus 5? 5. 3 minus 3?
0.
Okay, so I didn't think there would be any difficulty with that. Large numbers. We line them up. Hold on, I'm going to pause this. All right, so I'm going to have to regroup or borrow. I call it borrowing. It's also called regrouping. Okay, because I can't take 8 away from 6. Not in whole number world. So what I have to do is I'm going to borrow this 1, and I'm going to make this a 16. Okay, and I can take 16 minus 8, and that gives me 8. But now I'm in a situation where I have 0 minus 3.
Borrow.
I have to borrow again, because I can't take 3 away from 0, so I have to borrow 1 from this 6, which leaves me with a 5. And I'm going to give it to this 0, and that's going to make it a 10. So 10 minus 3 is 7. Okay, 5 minus 4 I can do. 4 minus 3 I can do. And then I have 3 minus 5. Again, I can't do that. So I'm going to borrow this 1 over here and make that a 13. And then 13 minus 5 is 8. All right, I need to borrow, but there's nothing to borrow from. So I have to go all the way over here to borrow. So I usually do this. Okay, this last number becomes a 10. Basically what happens is I borrow 1 from this 8 and I make this a 10, but then I borrow 1 from that 10 and I make it a 9. And then I borrow, that makes this a 10. Then I borrow 1 from that 10 and I make it a 9, and this makes this a 10. So when you have a row of zeros and you've borrowed, they become 9s up until the last one, which becomes a 10. Does that make sense? Okay. Then I can do my subtraction. Okay, so these are some keywords and what they mean. These are not all of the keywords. I'm going to give you a more extensive list of words and what they mean. At a later date in class, we're going to make like a whole list. But if you see the word sum, it's to add. If you see added to, increased by, or more than, those all mean to add. Plus means to add. Total of means to add. Okay, so when you see these words, if you're doing like a word problem, that means to add. Okay, these are available. Okay, 12 added to 109. That one's easy. Added to, add. So I'm going to add those together. Carry my 1. So I'm going to get 121. Okay. The sum of 1,386 and 376. So a sum means to add. Okay, so I get 1,762. When you're using these words right here, it's going to be up to sorry. Okay, I'm gonna star these with blue. Okay, the ones with the blue star, it's the first number minus the second number. Okay, when you have less than and subtracted from, it's the second number minus the first number. Oh wait, subtract 3 from 8. Yeah, I messed that one up. That one should also be red. That's what I thought. Okay, so these first 3 is first minus second. The last 3 is second minus first. And that's where it gets confusing. Because with adding, it doesn't matter. You just do it in the order it said, or it came in. With subtracting on some of them, you have to flip it. So just make sure to make a difference of 150 and 38. That's going to be 150 minus 38. Okay, because those go in order. And you have to borrow, so I get 112. 30 subtracted from, so that's subtracted from, that's one of the ones where you have to flip it, so it's actually 82 minus 30. Okay. Actuated for selected years. We have graph. Okay. As shown in the graph, we're going to find the increase in the number of robberies from the year 2000 to 2005, and then the decrease from 95 to 2000. Okay. Which again is right here. So we have 95 to 2000 is for B, and then 2000 to 2005 is for A. Okay. So between 95 and 2000, the robberies actually went down. And then from 2000 to 2005, they went up. And I don't know what the statistics are in the whole United States now, but it's probably, you know, like way.
Specify what kind of robbery?
No, just robberies. Okay, so what we're going to do, I have the space. Oops. Okay, we'll just do it on the side here. For A, we're going to subtract 581 minus 408,000. So that's how we find out how much it increased as we subtract. So it increased by 173. Or sorry, it decreased. Oh, I did B, didn't I? Went in order. Okay, so it decreased 173,000 over those 5 years, the number of robberies per year. For the increase here, we're going to subtract 417,000 minus 408,000. Subtracting zeros, always easy. Okay, 0 minus 0 is 0, 4 minus 4 is 0, so we went up 9,000 robberies between 2000 and 2005.